Hello. Zuid. I have no idea how to say that name. Hello. What's the best way to do good in exams? Good question. Well, I guess I could just start with me personally, what I do. I just make sure I am revising consistently over the entire course. So just make sure that my revision is consistent, whether that's like 30 minutes a day or, you know, an hour 3 times a week or something. I just make sure that I try to be consistent. And that usually works, but that's easier said than done. So of course it's hard to motivate yourself to always sit down and revise when you want to. There's so many distractions around and things like that. So yeah, that's it's difficult to be consistent with your revision. What else? I guess just identifying your weaknesses. And that really follows on from like consistent revision. If you're revising every day or, you know, a certain number of times a week, you pretty quickly identify where you need to improve. So you might be working on, you know, derivatives or integration or trigonometric identities or something, and you'll pretty quickly realize, oh, I don't know how to do this, I need to practice this more. Problem solving. That's probably the most difficult area to improve on, because I think it looks different for different people. But if you do have an issue with problem solving, I would say try to look for problems which you're not used to doing. So if you're having difficulty with problem solving, don't just do 100 of the same types of problems, like 100 algebra questions or 100, you know, solve for X or whatever. Try to look for questions that are a little bit different and challenge your way of thinking. And actually, games are really good for this. Well, many things are good for this, but one example is games, where games will often challenge you to think outside the box, as they say. So yeah, you'll need to think of different strategies and things in order to win the game. And well, I think that kind of develops that side of the brain where you are you know, the problem solving side of the brain that you also use in mathematics to solve those difficult problems, those difficult problem solving problems. So what are you studying for? Which are you, GCSEs or A-levels? Olamide, hello. How do you approach questions that you don't know how to solve? For me, I would try to look for something in the question that I know how to do, and Well, I have some experience now in that I can probably tell fairly quickly whether I can solve a problem or not. Or I'll be able to look at a problem and say, this looks like something I've done before, I can probably do this, or I've never seen a problem like this before, I probably can't do this. GCSEs, okay. So the problem that a lot of GCSE, a lot of people in GCSE mathematics have is they get to the exam and they have questions out of context. So when I say out of context, I mean you're not told what or how to solve the problem. So in a lesson, your teacher will say, here's Pythagoras' theorem. Let's do a bunch of questions on Pythagoras' theorem. And that's good practice, that's fine. You learn how to use the Pythagorean theorem, but then you might be given a question in the exam where all you need to do is to apply the Pythagorean theorem in the question, but it's hard to see because you're not told which strategy to use. So one way around that is to do things like exam style questions or worksheets with a mix of problems where you're not told how to solve them, and then you have to kind of identify the strategy first before you solve the problem. So that is one issue that is quite common. So yeah, practicing problems that you don't know the strategy beforehand as to how to solve them. And one good website for this is this website. I'll put it in the chat. I believe it's this. Let me just check. Yep. So this website is a good resource for practicing problems that look the same, but you actually need a different strategy in order to solve them. A-level. Hello M, hello Funny Sanju. Any topics or any questions that you would like to talk about? How many times should you check your exam, and ideally how much time do you want left when you finish your test? Good question. That's difficult because sometimes you don't know if you'll finish the whole thing on time. I would spend, a good strategy is to spend, say, 5 minutes at the start of the exam looking through the exam and figuring out which questions are going to take the most time and which questions you know you can answer. So I'm not sure if you can plan how much time you have at the end. I think that's kind of difficult, but you can kind of spend maybe 5 minutes at the start and sort of estimate which questions you should be spending the most time on. How many times should you check your answers? Well, I would suggest double checking the question after you finish the question. So if you can, it's not always possible to double check because there might just be, or you might only have one method that you know how to do, and it's difficult to say, oh well, if I did it this way, would I get the same answer? But you can kind of just check if you've got all the steps correct. Yeah, I would always do a quick double check at the end of the question and then move on. Maybe, a minute per question double checking. Hello, Akko Sophie. How would you approach a mechanics question in the exam within the time limit effectively? I tend to be able to answer the question, but it takes me too long. Yes. Time limits are difficult. I mean, I kind of have a generic answer for this, which is practice more of them and you get faster, but that's kind of an obvious answer, I think. Yeah, time is difficult. I've had students that were amazing in class. They understood everything, like they really understood the material in the class, but it was actually the pressure of the test that gave them poor test results. So it wasn't the fact they couldn't do the work, it was just the stress of the time limit that they struggled with. But I think your problem is slightly different. You're saying that you can solve the problems, it just takes you a little bit longer. That's difficult. Because I don't, I mean, the only issue there is the time, and well, it depends if it's like an ongoing thing, like like with more practice maybe you would improve, but if it's always like that, if it's always that you're running out of time, it might be maybe interpreting the question can sometimes take longer than it needs to. So maybe reading questions and kind of practicing interpreting what the question is asking faster, that can be a way to improve. Watching from Mauritius, cool. Adam, hello. Will we be expected to replicate the fundamental theorem of calculus for A-level maths exams? Replicate, do you mean derive? You need to be able to use the fundamental theorem. I don't think you need to prove it though. K Willow, I struggle with making small mistakes in my exam which cause my answers to be wrong. How do you prevent these? Yeah, I was just thinking about this today. So in GCSEs, one way to do that is to answer the question two different ways. And I know it takes longer. Hello, Gaming with VR, welcome. And I know it takes longer to answer a question twice, but think of the payoff that you don't actually lose those marks. So with the small mistakes, you know, you might be talking about, say, like you might add fractions and you make a tiny mistake with those adding fractions. So just do that adding operation or whatever operations you're doing, just do them twice just to double check. And that extra 20 seconds or 30 seconds that it's taking you to do that same operation twice gets you that extra 1 or 2 marks that you would lose otherwise. So it's kind of a payoff whether you think that you have that time to do that and whether you value those marks that you're missing, those small mistakes. So yeah, I was thinking about that today actually. I was just doing a GCSE paper walkthrough and thinking about, okay, so how could people avoid the small errors on this question? Well, here's 2 methods to do it. I hope that helps, or that's one strategy at least. The other thing that helps with small mistakes, I used to make those small mistakes as well. The other thing is that do worked solutions and then give it to somebody else and say, here's my worked solutions. Give it to a friend, and or even like walk through the question with a friend, and you pick up your own small mistakes, and weirdly that helps you in the future because you remember, oh, I made this small mistake doing this, like describing this to my friend. I'm not going to do that again. And it kind of, by talking to somebody about it or by describing it to someone, it kind of helps you remember it somehow. If I want to do maths at uni, will I need the advanced extension award in maths with my A-levels? Will universities like that? Advanced extension, is that further maths? I'm not sure what advanced extension award is, sorry. For A-levels, what are the most important chapters to focus more on? Trigonometry and calculus. If you're talking about pure mathematics. And then for mechanics, statics is a big topic. And for probability, the normal distribution, and using the normal distribution for hypothesis testing. Okay, it's not further maths, it's a standalone qualification run by Edexcel. Advanced extension. Okay. Sorry, I don't know, I can't answer that one. If you want to send me a written question, you can send it to my email, mathsexplained2@gmail.com. But if you just have a worded question, you can type it in the chat. What's 9 plus 10? What's 9 plus 10? What's 9 plus 10? What's 9 plus 10? 21. Is that what you're looking for? Shares and dividends. Not sure. Well, it depends what the question is. Feel free to type it, and I'll let you know if I can help or not. F1 Gamer, hello. F1 Gamer says Pascal's triangle. A very useful... what would you call Pascal's triangle? A very useful concept. Gives you the Fibonacci sequence. It gives you how to expand brackets. Gives you binomial distributions. Gives you heaps of stuff. How many lines in Pascal's triangle? Infinite lines. Here is my email. Okay, Terry. I answered that question. Do you have a different question? For A-level maths?
Sure I understand.
Whoa. Sorry about that. For A-level maths, do we need to learn about the Maclaurin series? No, that's in A-level further mathematics. What are the important parts to practice on with integration? The basics. So the different rules of integration. Actually, you don't. Oh, and the fundamental theorem. So finding areas with integration, I would say, would be the well, what's the most challenging part of integration in A-levels? I would say U substitution and integration by parts. They would be the ones, I think, where it gets difficult. Okay, Terry Johnson can have a break somehow. He can have some quiet time. Given that given that 5 root 7x on root 7 take root x equals 8 plus root y, where x and y are positive integers and root y is the third in its simplest form, find the values of x and y. Okay. Alright, let's do some algebra. Given that 5 root 7 on root 7 take root x equals 8 plus root y, find the values of x and y. Is this possible? Guess I'll find out, because I have one equation with two unknowns. We will see. How long would I revise when I was in high school? Yeah, about 30 minutes a day, I think. I would usually have homework and I'd just do my homework. Unfortunately, I did not apply myself enough in that I did not go beyond my homework, which I kind of regret. If I was to do high school again, I would pursue the areas. I mean, this isn't not really regret. It's just something that I think. Anyways, I would pursue the areas that I was most interested in. So mathematics was definitely an area of interest for me, but I kind of did not step beyond the bounds of the work that we were doing. So I didn't explore the problems that I found interesting. I didn't look at the parts of the textbook that we weren't set and things like that. I definitely would be doing that now if I had the chance. Well, that's what I'm doing with my YouTube channel, kind of exploring problems that I find interesting, areas of mathematics that I think are fun. I wish I'd done more of that in high school. It's 5 root 7 take root x as the numerator. Oh. Oh, 5 root 7. Take root x. Root 7 take root x. Okay. Okay. Alright, so I'll get to those other questions after I've done this one. Let's see. Well, as I said, there's two unknowns here, so I'm wondering if it's possible to solve. But what would I do first? I guess multiply by that denominator. Let's see if that helps. Oh, no. Just cancel. There's a much No. I was thinking, I was going to say just cancel this, but you cannot just cancel that, can you? Um, rationalize the denominator. Okay, why not? Let's try that. So, maybe this does something. Multiplied by root 7 plus root x all over root 7 take root x multiplied by root 7 plus root x. Okay, let's see what we get. This equals 8 plus root y. Okay, expanding these brackets. 5 root 7 times root 7 is 35. And 5 root 7 multiplied by root, well, they're going to cancel, and then we'll have a negative root x plus root x, multiplied by a positive root x. That will be negative x. On the bottom line, we have 7. Root 7 times root 7 is 7. The middle terms will cancel out, and then we'll have negative x equals 8 plus root y. Okay. Now what? Oh, yeah, of course. Oops. So this is still 35, but those middle terms there do not cancel out. That was a bit silly of me. This is 5 root 7 root x take one lot of root 7 root x. So that's plus 4 root 7 root x. Okay, weird. Take x. Okay. And then I guess we can factorize that numerator somehow. Okay. Yep. Oh, you don't need, well, you don't need to spam the questions. If I'm doing a question, then I'll get back to that one. Just give me a minute. So I guess we can factorize this numerator somehow. What would it be? No. Well, what would be the point of factorizing? We just get back to that same thing. Okay. I'm wondering if... No. Okay. Well, I'll keep going. Although I'm not seeing how this works out. So I'm going to multiply this denominator on the right hand side. So this would be like 8 plus root y, 7 take x. So 56 negative 8x positive 7 root y negative x root y. This is a weird question. Alright, so then let's combine like terms. 56 take 35. What's 56 take 35? 16, 21. 21. We've got 7x on this side. We've got 7y, root y, take x, root y. I don't know what to do with those ones. I don't know what to do with that one. Oh, wow. This almost looks like you could factorize this somehow, right? This almost looks like a... not really though. Seven x take 21 plus 4 root 7x. Okay. 7x take 21 plus 4 root 7. Is it just x? Oh, it is just x. Here. Ah. No, it's not. It is root x. It was 5 root 7 multiplied by root x take root x root 7. So that's still a root x here. Equals 7 root y take x root y. Oh yeah, you can combine that. I see. Oh, this is like a quadratic kind of. Okay. So actually you can write it like this. you can factorize this, and I guess this factorizes out. Wow. Crazy. There must be, surely there's an easier way to do that. Okay, so I was just thinking, could I factorize this? But I don't think. I mean, maybe you can, but I can't. I can't see the factors. Oh, so oh right. So this was not the way to go. I see what you mean. So here you're saying 7x take 21 is that must be a this must be a whole number. But why could this not be an integer? I don't understand that. Why could y not be a square number? What's to say y could not be a square number? Oh, I did not read that. Root y is a third? Where does it say? Where did it say that in the original question? Root y is a third in its simplest form. Okay, alright. Yeah, well that makes sense then. So if root y, so we should say root y is a third in simplest form. Right, so then this must equate to 0 because this cancels out. There is no whole number on this side. This is well, these terms are in their simplest form, so we can say 7x take 21 equals 0 and x equals 3. Okay, wow, interesting. I feel like, could you not just expand this, or do you have to do all of this? Maybe you do. Let's just see. So what if I just multiply on this side by this? So we get 5 root 7 take root x equal to 8 root 7 plus root 7 root y take 8 root x take root x root y. Okay. So the problem there, I think, is that you have that root x with the root y, probably. So that means that you probably can't solve it that way. Whoa, gaming with VR. There's a lot of spam in here. Alright, that's enough spam, kids. A man brought 500 shares each on space value rupees 10 on certain business concern, and during first year after purchase he received 400 as dividend on shares. Find the rate dividend on shares. The rate dividend, space value. I don't know what space value is, sorry. Alright. Haven't quite finished yet. I was just seeing, is it possible to do it this way? But I think that the root x root y means that you have to actually take all of these steps. So you do not end up with a root x root y. Well, that's my theory at least. Okay, so then how do we solve for y? Plug it in here. We have 4 root 7 times 3 equal to 7 root y take 3 root y. 4 root 21 equals 4 root y. Well, they're positive integers, so we can square both sides. Oh, just divide by 4. No, what? Well, y what am I doing? Clearly y equals 21, right? You can just read it straight from this equation. 4 root 21 equals 4 root y. What is y? Y is 21. Okay. Interesting question. The fact that y is asserted in simplest form is added in there is interesting. Or root y is asserted in its simplest form. So what does that mean? That means does that mean y is a prime number? So yeah, right? No. Well, it could be also a product of prime numbers. Because you can write this as root 5 root 3, but is that any simpler? It's kind of still the same thing. Alright. Thank you for that one, Veer. And thank you for all your help. Any other questions? I think somebody possibly sent one to my email. Let me just double check. Okay, I have a couple of problems here. Cambridge admissions testing, right. Question 1. So, John sent me a Cambridge assessment admissions testing example paper and was asking about question 1. I am not sure whether to give it a go. I probably would not be able to give a decent explanation, but let me know. What do you think? Should we have a look at that question or not? Lol says yes. Okay, we can at least have a look at it. I don't promise anything too spectacular, but well, let's have a play around. Maybe we can give it a go at least. Okay. Yashi. So I read through this problem before, and I said I don't know what face. Oh, you changed the wording. A man brought 500 years each the face value of rupees 10 on a certain business concern. 500 years. on a certain business concern, and during first year after purchase I received rupees 400. Yeah, I've forgotten what face value, and I'm not sure what 500 years of face value means. Apologies, Yashi. I'm not sure I can help with that one. Okay, so this question here was sent from the Cambridge, well, basically the entrance, what do they call them? Admissions testing. So I believe this is the type of test you do for university, but I'm not 100% sure on that. I didn't go to university in the UK, so I'm not sure how it works. But let's see. So this question says a straight line passes through the fixed point 1k and has gradient negative tan theta, where k is greater than 0 and theta is between 0 and pi on 2. Find in terms of theta and k the coordinates of the points x and y where the line meets the x and y axes respectively. So this is kind of confusing. So is this the first question here? And then this is the second part, or is this how you get to that answer? I'm already lost. Anyways, let's see if we can answer this part. So find in terms of theta and k the coordinates of the points x and y where the line meets the x and y axes. Okay, so if we have a gradient of negative tan theta, we could say that the equation of the line is negative tan theta x plus c. That's one possible starting point. So then you could use that point 1k. Okay. So you could use that point substitute it in here to get an expression for c. Let's see what happens if we do that. So we could say k equals negative tan theta plus c. So c equals k plus tan theta. Alright, so then we can say therefore y equals negative tan theta x plus k plus tan theta. Alright, so then the y-intercept is k plus tan theta. And when y equals 0, we have, so the x-intercept is when this equals 0. So we have negative, we would have negative tan theta x plus k plus tan theta equal to 0. And we want it in terms of theta and k. Oh, we want the coordinates. Well, the coordinates for the y-intercept were 0, k plus tan theta. And the coordinates of the x-intercept, so solving this in terms of x, we would have negative tan theta x equal to negative tan theta take k, and then x equals negative tan theta take k all over, well, the negatives actually you could divide through by negative 1, and then you have tan theta plus k all over tan theta. So the coordinates there would be tan theta plus k on tan theta, 0. Alright, so whoever sent this question, are you still in the, watching the live stream? Hopefully this is helping somebody. I believe that is an answer to the first part of the question at least. Okay, part 1. Find an expression for the area A of triangle OXY in terms of k and theta. The point 0 is the origin. The point O is the origin. You're given that as theta varies, A has a minimum value. Find an expression in terms of k for this minimum value. As theta varies, A is a minimum value. Okay. Alright, so I might just stop at this one because I have to go in a minute. But to find an expression for the area, I guess we would do the base times the height divided by 2. So the height is k plus tan theta. K plus tan theta. The base is tan theta plus k on tan theta divided by 2. Or actually, an easier way to write that might be just to multiply it all by a half. And then expand that out. Actually, an even easier way to write this might be to write it as 1 plus k on tan theta. Yeah. 1 plus k on tan theta. And then let's expand these brackets out. I might just leave that half where it is. So we'd have k plus k squared on tan theta plus tan theta plus k, and then we get 2k plus k squared on tan theta plus tan theta. Oh, I guess you can combine those. So tan 2k tan theta plus k squared plus tan squared theta on tan theta. 2 tan theta. Okay, that's the expression that I end up with for the area for part 1. Two k tan theta plus k squared plus tan squared theta on 2 tan theta. And then we have a minimum value for A. So what would give a minimum value here for A? Ooh. We could find the derivative of that. You could try to find the derivative of A with respect to theta. Actually, it might have been easier to leave it in this form than if you're going to take the derivative, because then you just need the product rule. Okay. So let's say A equals k plus k squared on 2 tan theta plus a half tan theta. And then you need to derive that. I guess. And well, that's how I would tackle that problem anyway. But I'm not sure if the person who sent this question in is even watching anymore, so but there's a strategy for the first 2 parts of that problem at least. Okay, is anybody well, it's 2:30 already. Are there any other topics anybody wants to talk about before I head off? I am originally from Australia. Mauritian, cool. I'm having problems on coordinate geometry. Can you help if I send the problem to the email? Yes, please send away. I'll be going on break soon, so I probably won't be live for a while after this. I might be doing a live stream tomorrow, but that will probably be my last one for a couple weeks. Alright, any other maths topics or maths questions? Probability. Which level? Alright, I might play one game of something. Yeah, why not? Let's play one game of chess before I go. And I played a 10-minute game last time, so I think I'll play another 10-minute game. So let's see how I go. Any chess players? Feel free to tell me the best moves. Um, What music is this? C418. He's the guy that did all of the music for Minecraft, I believe. Ogdenjank resigned. Wow. No problem, Akula. Alright. I guess that's about it from me. Akula, you haven't played chess in quite a few years. Well, it's always good fun to get back into it. I played when I was younger, and I was the same. I haven't played for, let's see. Yeah, quite a while. I haven't played for quite a while. But I seem to remember something, so that's good. Against computers. So this website, you can play against computers, but generally play against other people. This is lichess.org. So you click on whatever time you want and you'll be matched with another person. But you can play a computer if you want. If you go to I think you can somehow. Alrighty, I might see you all tomorrow if you want to tune in tomorrow. Have a good evening. Catch you next time. Bye.